After suspending a body of mass 1 kg from a wire of negligible mass, length 1 meter and radius 1 millimeter, it is made to oscillate along the length in a vertical plane. Its frequency is found to be 100 per second. Young's modulus of the elasticity of the material will be equal to. Now, first of all, let us understand what is happening in this sum. If I consider a fixed wire which is attached on the ceiling or whatever it may be, initially it was at rest. As soon as I attach a mass over here of, let us say, mass over here I am attaching over here is m, okay, and I suddenly leave the mass, okay, this wire will initially expand, okay, by, let us say, delta L, due to this mass. But due to the restoring force, this wire will start pulling this mass in the upward direction, okay, and again it will get contracted, okay, by the same length delta L, it will again get contracted by the same length delta L, then it will again expand and it will again contract. So basically it will perform an SHM. So basically this for this given body, the body is performing an SHM. We have to find out the total Young's modulus using the formula of the SHM. Let us first see the formula of the force applied at different points, okay. If I consider the formula of the Young's modulus, Y will be equal to F divided by A delta L divided by L. So basically F will be equal to YA by L into delta L. Now if you see, the force is directly proportional to delta L. So that is why this will perform a simple harmonic motion, okay. The force will be directly proportional to delta L, and I can say it will be negative, okay. Why it will be negative? When the mass is pulling the rod in the downward direction, the restoring force is pushing it in the upward direction, and when the displacement is in the upward direction, the restoring force will push this in the downward direction. So the force is in opposite direction to that of the displacement. So I can say that F is directly proportional to delta L, therefore that this will be an SHM. So this will be the value of K using the formula F is equal to minus Kx. This will be the value of K. So K over here is given as YA divided by L. So K over here is given as the spring constant. In this case it will be a constant of vibration. It will be equal to YA divided by L, okay. So basically the K over here is equal to YA divided by L. Now there is another formula. Let this be equation number 1. There is another formula for omega. Omega over here is equal to root of K by M. So I can say that K will be equal to M omega square, okay. K over here will be equal to M omega square, okay. That is the spring constant. Let this be equation number 2. Now over here omega will be equal to 2 pi f, okay. That is the frequency of the given vibrations, okay, and the mass is specified. Now let me substitute the K value of K over here. It will be equal to YA divided by L, okay. YA divided by L is equal to mass into omega square. Omega square can be written as 2 pi f the whole square. So let me substitute the values over here. The Young's modulus is given as, the Young's modulus over here of this part is given as, okay, we have to find out the Young's modulus, okay, The area of the wire is given as, the radius is 1 millimeter. So the area will be equal to pi into 1 millimeter square. So it will be equal to 10 to minus 3 the whole square divided by length. The length of the wire is given as, specified as 1 meter. The mass attached is equal to 1 kg into 2 pi f. So when I square this part, okay, it will be equal to 4 pi square into f. F over here is given as 100, okay. F over here is given as 100, so it will be equal to 100 the whole square, okay. Now when I substitute the values, the Young's modulus will be equal to, the 1 will not play any part. It will be equal to 4 pi square divided by pi square into 10 to minus 6 into 10 to 4. So pi, this will be pi, not pi square. At the bottom, at the denominator, this will be equal to pi and not pi square. So this will be equal to, pi and pi square will get cancelled out. So it will be equal to 4 pi into 10 to 10. So basically it will be equal to 12.56 approximately into 10 to 10 Newton per meter square, okay. 10 to 10, okay. 12.56 into 10 to 10 Newton per meter square, which is equal to 1.26 into 10 to 11, which is equal to option number B.